right, welcome back again. This is Investigation 7. I find investigations a little bit difficult to do in this format because they are investigations that needs more interaction back and forth, but we're going to do what we can. The schedule for today and Friday. Today we're going to look at Investigation 7, and that's it. So your homework, you'll have some homework. It'll be the A, B, C, and D for Investigation 7. Friday we'll score Investigation 7 and then I'll give a test review and you will study for that test over the weekend. We will take the test Monday hopefully. If I get all the papers around and everything that we need, we'll see if that works with your schedules, your pick up and drop off packet. But anyway, that's what we're trying for Monday for the test. Alright, Investigation 7, it's page 470, and this is just more investigating trigonometric ratios. So sine, cosine, and tangent is where we're going. Again, to review, top of the page, the sine, cosine, and tangent ratios for a right triangle are as given the sine of angle x. So we're using the drawing down here. The sine of angle x is opposite over hypotenuse. Again, look down through the Oscar had a hold on Arthur. OH, sine is O over H, cosine is A over H, tangent is O over A. So notice that tangent x is a quotient of sine of x and cosine of x, whatever, we'll skip that. What we're going to do in this investigation, I want you to draw a chart, to make a chart, so get a piece of paper and copy that chart that's in the middle of page 470. And we're going to fill that in. So you can make it as nice as you want. Over here is going to be the angle, you can label x or the angle measure, whatever. And then the next column will be the sine of that angle, the cosine of that angle, and the tangent of that angle. And then we need to have lots of spaces in here. We need to have 1, 2, 3, 4, 5, 6, 7. We need to have 7 rows. 1, 2, 3, 4, 5, 6, 7. Also put these columns in here for nice neatness. Make this chart, and then we're just going to compare these, and we're going to look at them from 0 to 90 in increments of 15, like the book says. Starting with a 0, 15, 30, 45, 60, 75, and 90. Did I do that right? From 0 to 90 in increments of 15. This is degrees. These are all angle degrees. You can put degrees on here if you want to, but these are all degrees. And then let's fill it in. I wish you were here so we could actually make you talk. But let's start with just like the book says. Number 1, imagine a right triangle with one angle measuring 0. Now that's kind of hard to do, but I'm going to come here and draw a triangle. This is a right triangle. This is really big. I don't like that bell. One leg is really big, one leg is really, really small. But we're going to enlarge it just so we know what we're talking about. Here's the right angle, and then this is the hypotenuse. Now I drew this, and this is obviously an angle because you can see it there, but if I drew that, if we consider this angle as 0, we're looking at this angle, and we say the measure is actually 0, then these two lines are right against each other, and that tells us that this hypotenuse and this leg length here are both going to have the same length, and this length down here is 0. So for this funny triangle that only exists in our mind, this side length is 0 inches right here, and the hypotenuse is here, and it is equal to adjacent. So in this funny triangle, adjacent equals hypotenuse, whatever it is. And let's just pick a number. Let's just say that I made this triangle to be whatever I made it, 12 inches we'll say. It's bigger than that, but 12 inches here for the hypotenuse. So hypotenuse equals 12, adjacent equals 12 as well because they're tight together. So sine, cosine, tangent. Oscar had is sine, cosine, A, hold on Arthur, tangent. So the sine of 0 is opposite, which is this one, over hypotenuse. So 0 over 12. And if you use your calculator, and you can do this, 0 sine will tell you, but the other way to check it for sure is that the sine of this angle 0 is 0 over 12. So if you go 0 divided by 12, I hope you get 0. The sine of x is 0. Cosine is adjacent over hypotenuse, which we said are equal. So 12 over 12, that simplifies to 1. Tangent is opposite over adjacent, so again it's this 0 on top over 12. So 0 over 12, just like the sine. For a 0-degree angle, the sine and tangent are the same. It's 0. All right, let's skip down to number 2, which is a 30, 60, 90. So we're going to leave this 0 guy. We'll come back to him at the end. But for now, we're going to erase him and go to a 30, 60, 90 with shortest side being 1. So remember the ratio of side lengths of a 30, 60, 90. This is 30 degrees. This is 60 degrees. 1, 2, square root 3. 1, 2, square root 3. Now use this for 30 and for 60. If you look carefully, let's start with the 30 right here. The 30 row, the sine of a 30 degrees, so we're looking at this up here. The sine of a 30 degrees opposite over hypotenuse. Opposite is 1. Hypotenuse is 2. So the sine is 1 over 2. The sine of a 15 degree, or 0.5, whichever way you want to think about it. But the sine of 15 is 1 over 2. 1 over 2. That's the ratio. In this case, these are our side lengths, but this is also the ratio. 1 over 2. The cosine is adjacent, that's this one, over hypotenuse. So square root of 3 over 2. And if you rationalize that or put it into decimal form, it is 0.87 almost. So approximately 0.87. We're just going to do that so we can memorize or recognize these numbers. Tangent opposite over hypotenuse. Again, you're looking up here, so which one is opposite? That is 1 opposite over, did I say hypotenuse? I meant adjacent. 1 over square root of 3. Now, remember that we don't like square root of 3 on the bottom, so we take this, can you see that? Take this times square root of 3 over square root of 3, since we're allowed to multiply everything, multiplying it by 1. This right here is simply 1. Whatever this is, it's the number 1, so you can take a number times 1 and it won't change it. In this case, it makes, put the equals down here, and you get square root of 3 on top, and you get 3 on the bottom, because the square root of 3 times the square root of 3 is 3. So that goes up here. For the tangent of 15, it's the square root of 3 over 3, and that is approximately equal to what? 0.58. All right, jump down to 60. Now we're going to use the same diagram here and just switch our perspective. Now we're looking at this angle down here. So the sine of 60 again is opposite over hypotenuse. This time opposite is this one. So square root of 3 over 2 is the sine. Square root of 3 over 2, and we just had that one up here, so that's approximately equal to that 87. And then cosine is adjacent. Am I doing this right? Adjacent cosine. Yeah. We're here, adjacent is 1 over 2. Which we already had again, 0.5, that's this one here. This one goes to here, this one goes to here. The sine and cosine flip when you have, that's my problem. We're looking at 30. You guys are probably here just screaming your heads off that all this row needs to go down here. Well, why didn't you tell me? I like that better. We'll come back to 15 in a minute. Sorry about that. And then the tangent of a 60 degree is opposite over adjacent. We're down here, so opposite is square root of 3 over adjacent, which is 1. Square root of 3 over 1, that's simply square root of 3. So the tangent 60 degree is the square root of 3, which is approximately 3.73. 1.73. There. 1.73. So you should be filling in this chart with me. Hope you are. All right, there's our 0, there's our 30, and our 60. Let's go to 90. And we could have done this one while we had this other triangle up here. But let's go to 90 right now. So back to this funny looking triangle. I'm going to draw it the same way. Here it is. I'm exaggerating, but this is the angle. And we're pretending that this is 0. And it has to be 0 because this is 90. We're pretending that this angle down here is 90. Just like this angle is 90, this one is 90. If we have a 90 down here and a 0 up here. Now, we can't draw that because it would just look like this. Just a single line, and the hypotenuse and the adjacent would be there. Again, opposite is 0. Or not opposite, but this leg is 0. Now we're dealing with this 90 degrees, so we're looking at this angle right here. This is 0, and these again, we'll put our 12s up here just for. This is still the hypotenuse. The hypotenuse is here, and then in this case, this is the opposite. Again, opposite and adjacent, they change according to your perspective. Opposite and adjacent. All right, let's fill in this 90. So the sine is opposite over hypotenuse, and opposite of this 90 is this 12, and the hypotenuse is 12, so 12 over 12, just like we had up there, becomes 1. 12 over 12 is 1. That's for the sine of a 90 degree is 1. The cosine is adjacent over hypotenuse, and adjacent is 0. That's this one. So 0 over 12, 0 divided by 12 is 0. So that becomes 0. Now here's an interesting one. If you use your calculator, well, we'll get there. Tangent is opposite over adjacent. So opposite is 12. 12 over adjacent, adjacent is 0. Everyone get your calculator out and put 12 divided by 0. And mine says that. E. Yours probably says error or syntax error or something. I think we did this before, but calculators do not like to divide stuff by 0. They can't divide stuff by 0. It just goes to nothing. So we're going to put error or undefined. We don't know what it is. We don't know what the tangent of a 90 degree angle is. We can't deal with it. It's just going to have to be this error down there. Now, go to the middle. We could have done this one earlier, but let's go to the middle one and do a 45, 45, 90. This is the right angle. And I think it tells us, yeah, legs of 1. So this is 1 and this is 1. We know our ratio. Since this is 1 and this is 1, this is square root of 2. That's a 45, 45, 90 triangle. 45. All right, we do the same thing as we've been doing. The sine of a 45 degree, it's opposite over hypotenuse. So we're going to do this one. It doesn't matter. We could do down here. 45 degree, opposite over hypotenuse. In this case, this is the opposite. This is the hypotenuse. This is the adjacent. Adjacent, hypotenuse, and opposite. So the sine is opposite over hypotenuse, so 1 over square root of 2. And we don't like that. 1 over square root of 2, we don't like that in the bottom. So again, we're just going to take this times square root of 2 over square root of 2, just like we did the square root of 3. So we do this and you get square root of 2 over 2. That is the sine. So square root of 2 over 2, that's the sine of a 45 degree angle. And you could make this one become approximately 0.71 if you decimalize it. There is such a term. All right, cosine of 45 is adjacent over hypotenuse. Cosine of 45, this is adjacent here over hypotenuse, 1 over 2. And surprise of surprise, we get 1 over square root of 2, just like the other one. So do what we did and you get square root of 2 over 2. That is equal to 0.71. So for a 45, 90, the sine and the cosine are equal. Tangent is opposite over adjacent. We're up here, so this is opposite and this is adjacent. 1 over 1. 1 over 1 is a big 1. just use our calculators for this, so please get your calculator out and tell me what the sine of a 15-degree angle is, somebody. 15-degree angle, the sine, and if we go into hundredths like we were doing, it is approximately what? Can't hear you, say it louder. Still don't hear you, okay. 0.26. Hopefully you got. Cosine of a 15 degree, the cosine, approximately 0.97, just barely, approximately 0.97, and the tangent of a 15 is approximately, did I do that right? Approximately 27.27, I did, that's funny. This is 0.26 and this is 0.27, but that's how it is. We should understand that, but again, these are all approximates. Any decimal on here is approximate. We're just, that's why my things go like that. Approximately. And we'll do the same thing for 75. So 75 degree, the sine is 0.97. The cosine of 75 is 0.26. And the tangent of 75 is 3.73 approximately. Now, a couple things about this chart. First of all, we ran on to looking at 30 and 60. But if you look at the sine of a 30 and the cosine of a 60, they're equal. If you look at the cosine of a 30 and the sine of a 60, they're equal. If you look at the sine of a 15 and the cosine of a 75, they're equal. And the cosine of a 15 and the sine of a 75 is equal. They cross over. Actually, what it is the sine of an angle and the cosine of that angle's complement. In other words, remember complementary, 90 minus 15 is 75. So you have an angle in its complement. This is 15 and the complement is 75. Complement is whatever makes 90. So the sine of an angle and the cosine of its complement are equal. The cosine of an angle and its sine, the sine of its complement, is equal. And that's the same case for this one. 45 degree, the complement of 45 degree is 45 degrees, so the sine and the cosine are equal. Same thing for 0 and 90, the complement of the 0 is 90, so the cosine is equal to the sine. The cosine of 0 is equal to the sine of 1, cosine of, or 90. The sine of 0 is equal to the cosine of 90. This chart, they just flip each other as you go down through here. This one starts at 0. Well, first of all, the range of both of these is from 0 to 1. 0 is the smallest possible cosine you can ever, or sine you can ever get, and 1 is the biggest possible. In fact, it's kind of impossible because that's the triangle that only exists in our imagination. 0 to 1 is the range of values for sine. 0 to 1 or 1 to 0 is the range of cosine. Tangent is the only funny one. He goes from 0 to 3, here's the number 3, and then it's undefined. Now, take your calculators and drop them, like I did. Pick them up again, and let's go in between here a little bit. Let's say, so the tangent of 75 is 3.75. What is the tangent of an 89 degree angle? That's as close as we can get to 90, right? So 89, the tangent of 89 is 57.29 approximately. Well, that's kind of a funny, and he goes in between here. That's kind of a funny word, funny number. That's for 89. That is the tangent of an 89 degree triangle. What about 89.9? 89.9, the tangent of 89.9 all of a sudden becomes 572.96. So almost like 100 times bigger. And that went from 89 to 89.9. Now take your calculator and go 89.999999. We're going to make an angle that's as close to 90 as we can get. We don't know what 90 is, but let's get as close as we can with our calculators. 89.999999, and put the tangent in there, and what do you get? You get a huge number. 572957795. The tangent of 89.9999999, however many there is 57,295,77. Well, I did that wrong. It's 572,957,795.1. That's the tangent of an 89.99999 number. So really, and if you could go bigger, if you have a longer calculator, which you could on your phones maybe, if you get the tangent or find a scientific calculator on your phone, and get the biggest number you can, the angle that's closest to 90, again, it'd just be 89.9999999, and somebody talked about this number repeating, it's equal to this. We're going to go as far as we can. The more nines you put, the bigger this tangent would get, and it would just get, so it actually goes to infinity. It's kind of like the tangent of a 90-degree angle is infinite. It's, I don't know, that's scary. So the chart comes out really nicely, except for this little bottom one right here. But we can understand this crossover here between the angle and its complement, and the range of tangent is 0 to infinity. I like it. All right, so we're going to look at the top of page 471. What did you notice about the sine and cosine values of the 30 and 60? And we did that. We didn't quite do how they did it, but the 30 and 60s are switched of the cosine and the other ones as well. And so we talked about the sine and cosine of the complement angle, other they're equal. Describe the range of values for cosine and sine, which we did. Sine goes from 0 to 1, cosine goes from 1 to 0, and range of the tangent function. Make a conjecture based on your table and test it by calculating the tangent of some other angles with your calculator. And I don't know what the book actually says. I should have looked at that. But what does the book actually say for what is the range of the tangent function? We are saying it's from 0 to infinity. And that's kind of a bold statement. I should have maybe looked this up. The tangent of a number is bigger than 0. That's what it says. Something bigger than 0. Well, that's helpful. The two legs can have any positive measure, so the ratio of their lengths can be any value greater than 0. In other words, it can go to infinite, as big as the triangle that you make. Anyway. All right, that's it for this. We're just, again, kind of looking at sine, cosine, tangent. I hope you made that chart. You can save it and refer to it just to get this switching deal. But if nothing else, it was practice, again, looking at an angle using this. It always is based on your perspective. What angle, the sine of what angle are you looking for? You station yourself at that angle, and that's when you decide what's opposite and what's adjacent and so on. So your investigation homework is A, B, C, and D. It's not really hard. Exact values are in there for 1 and for A and B. It says to give exact values. That means square root. Leave the square root numbers in there. A, B, C, and D is your homework. For Friday, have that done for Friday, and then we will score that, talk about it, and also do a test review Friday.